Hi, and welcome back to Media Computation and Data Science. Today, in this unit, I'm going to show you how to visualize frequency distributions. Just a quick little tool that can get you surprising insights. So let's jump right in. In Snap, let's open again our Titanic passenger data set. Go to titanic.csv, drag it into Snap, and here we are. We can close the dialog box and import the frequency distribution analysis library. Here we go. Those blocks we need. And we're again going to look at the age distribution. So the age is in column 5. So what we can do is we take the Titanic, we go to the control category, get out the pipe block. So from the Titanic data set, we take all but the first of records. So we leave out the title row, and now we want to group them by the age, which is in column 5, item 5. Let's actually check this out. So this works out, and now we want to sort it by age. So we're getting out the sort block, in here, and as a sort predicate, we're sorting in an ascending order, so it's the lesser than block, and we take the first column of our result, and here we are. This is the age distribution of the passengers of the Titanic. Now, if you look at those numbers, you'll find out that some ages are funny here. They've got fractional ages, like I guess that's 3/4 of a year. But also we've got some half years here. So what we want to do is we just want to get full years. So in order to get full years, we can just compute the grouping function, and instead of just taking it as it is, we can round it. So we take out the round block, put it into the group ring. Now we're grouping the ages by their rounded ages, and now we only have full integers as ages. Now if you look at the age distribution here, we pretty much got an entry for every conceivable age, starting at age 0, which is surprising for the passengers of a passenger ship. And then it pretty much goes up until the age of 80. But as you can see, as people get older, passengers become fewer, so we're missing a couple of ages here. It goes up to 71, then we're missing 72, 74, we're also missing 73. So what we want to do is we want to get a complete range of numbers of possible ages, and so also for the missing entries, we want to get the key of the age and a 0. So this is actually what we call a histogram, and we have a block for that in the library. There is a histogram block, and it works pretty much exactly like our group block. There's 2 versions of the histogram block. For the purpose of this exercise, we're going to take the lower one that has 2 rings. So instead of grouping and sorting, the histogram block does all of this in one step. So we take the histogram of all but first of the passengers of the Titanic, and we're grouping them, and we take the same grouping expression that we used in the group block, so we get the full integer ages, and then we want to get a range from 0 to 100. Now we know that no passengers on the Titanic were older than 80, but bear with me, you'll understand in a while why we're doing this. And in the interval ring, we can specify an expression of the granularity of values we want to see. So here we want to get an entry actually for every year. So we're going to put in the +1 block. So now if we click on this, we get a table that already is sorted. In the first column, we're getting all the ascending values, numbers from our bottom to our top value, always +1. And in the second column, we're getting the aggregated values that are found in the database. So this is our age distribution of the Titanic, and this is what we call a histogram that also has entries for missing groups. Once we have a histogram, there is a nice way to just see what it does. So if we look at the histogram, we have the interesting column is the one in the middle. The one in the middle that actually has the values, the ages. This is pretty much similar to the frequencies that we analyzed with the microphone. So if we want to plot these, to visualize these, we're just interested in this second column. Remember, we're getting a column using map. So we're expanding our pipe expression by 1. We're putting in the map block, and we're getting that second column. Has to go in here, the second column. Now I'm getting a list of numbers. These are the ages. Now, one way to work with data is just to have a very quick glance at its distribution. So in the pin category, we have something that plots bars, that plots a list of numbers as bars in a viewport. So I can take in this whole expression. This is the list that I'm going to plot the bars in, and I'm going to plot it in the middle of the stage. So if I click on here, what I'm getting is the bars of how many people are of which age the passengers of the Titanic. And this is a curve that many histograms will have. It's a bell-shaped curve, kind of like the bell in a church steeple, and this is often what comes out of frequency distributions. So now that we've done this for the passengers of the Titanic, let's compare it to the age distributions of billionaires in 2014. So into the same project, we're importing the billionaires data set. And here the age is in the first column, but we first need to filter it for the correct year, which is the 22nd column. So again, what we're doing is we're getting out a pipe block, we're filtering the billionaires, which is keeping the items that equal the year 2014, and that year is found in the column 22. So now we're again getting the subset of the data we're interested in. And if you look at the age column, there are some persons that have an age of -1. Now that is important. Looking at data, sometimes you notice these things. -1 means we're actually missing the age. So for the purpose of getting a big picture, we want to filter out those billionaires whose age we don't know. So we can make this expression a little more complex by adding an and. We say we want all those for the year 2014 whose age is greater than -1. That age is found right in the first column. So our filter expression is a little more complex. Let's try this. So now all the ages in here are larger or greater than -1. We only have those that we know. So this is almost it. Now what we can do is we can get the same histogram. So in the next step, we're taking the histogram. Remember to take the bottom one. We're grouping it by the first column. And we don't have to round it because we only have integers in this database. We're grouping it from the first column. We're starting at the age of 0 to 100. And we're setting the interval to the same +1 thing. And now we also want to get the second column from that database. So we're duplicating this. And now we want to plot this. So we're taking the plot block and we're embedding the expression into plot. I'm going to hide the table. And I'm actually going to clear what we already have here, which was the passengers of the Titanic. And now let's compare this to the age distribution of the billionaires. Okay, so this is slightly different. It's another very distinct bell curve. And what we can now do is we can plot the billionaires in a different color. So for the billionaires, we take blue. And for the passengers of the Titanic, we take red. And now we can compare the age distribution. And it's kind of interesting how the passengers of the Titanic were so very young compared to the billionaires of 2014. And we can muse whether it just takes longer time in your life to accumulate riches, or whether the people in 1912 were just generally younger. As you can see, this is not exactly high science. Histograms are a way to quickly grasp some essentials of data, to get a quick overview, to compare comparable things to each other at one glance. Now, we've got a bunch of things for you to discover today and this exercise. In fact, you're going to now take it one step further and reapply this idea of a histogram from data science back to what you've learned from media computation and do a data science analysis of a photograph. And I can imagine this is going to be great fun. See you in the forums.